Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, welcome back with me Ahmad Azharin in Computer Graphics. Uh, this is our third meeting and I want to share about the line algorithms. So let's start from the beginning. I want to start my presentation. Okay, line algorithms. What do you know about the line algorithms? Before we start our explanations, I would like to explain you about our learning outcomes. First, I hope you all can explain the concept of drawing lines in computer graphics after this class. You also can describe the algorithm for making lines. And the third one is I hope you can know about the advantage and disadvantage of the line algorithm. Okay, before we continue the explanations, I would like to know about what is your understand your knowing about the line. What is a line? Okay, as you can see on the screen, the line is connecting between 2 points. So the lines means the 2 point that was connected. So what is the problem with the line? That was so easy when we drawing a line on a pixel. We can drawing by put on the 1 point to next point, yeah, and we can draw it by making a straight line. So it's easy if you drawing on your paper, yeah, it can easy when you're drawing on paper, but we found that when we drawing a line, we found some problems. If you're drawing a line in a computer with a pixel based, we would like to know about what the next, what pixel will be drawn next. As you can see on the screen, yeah, if you see the pixel, as we explained before, that the pixel is the small unit, the small, the small unit of the computer graphics of the screen. So the pixel means the small unit, the small, what kind of, small unit of the pixel of the screen. When we try to drawing on the computer or the screen device, it would like uh, to see as your uh, screen right now. There are consisting by a few or some or multi point that making some column and some row. So it will be some pixel that when we put 1 point at the top one, yeah, and the last point at the bottom one, so it will come, it will pass into the next into the next row, yeah, or the next column. As you can see that the point to make the line, it make for column, yeah, with the point after that. Point next will that will be drawn, or if you see from the row side, yeah, the row side will make two row, yeah, to get one line. Okay, when drawing a line on a pixel-based screen, which pixels will be drawn? When we're drawing a lines, yeah, should look good by minimize the jagged effect or the minimize of aliasing. Line also has a uniform line thickness. It should be takes a short time to draw. That was the problem. So it was easy to make this happen, to make these solutions by using the line algorithms. Okay, the first line algorithm that would be explained, it was the straight line algorithm. When you see on the screen, there is y-axis and x-axis. Yeah. As you can see, straight line equations will be y, yeah, equals m uh, multiple by x and plus by b. M was a gradient and the b is the y-intercept. If there are 2 points that will be connected by x1, y1 and x2, y2, then the gradient m can be calculated by using these equations. M or the gradients is equals by uh, difference of y divided by difference of x. So the gradients can be calculated by using the equations difference y divided by difference x. Oh, as you can see, the y2 will be minus by y1 and the x2 will be minus by x1. After you got the gradients, you also search for intercept or b, yeah, that can be calculated by using these equations. Using the gradients that you have reached before, yeah, the b equals with the y1 minus m y minus gradient multiplied by x1. So if we got the 2 points x1 and y1 and x2 y2, you can see on the right, yeah, on the right side, x1 and y1 is on the top, sorry, on the bottom one, and the next point on the top one. For example, when we reach differences of y, you can reach by y2 minus y1, and difference of x or delta x, you can reach by um, minus x2, yeah, to the x1. Then we can also, yeah, get the equations from the differences. The delta y or difference y's equals m or gradients multiplied by difference x or delta x. That's also equals that delta x equals by difference y or delta y divided by m or gradient. So what is the functions of the gradients? As you can see after this, yeah, you can use m as a slope. Yeah, you can use m as slope. In bahasa, you can see that such a kemiringan. Yeah, if, yeah, if m, yeah, if m less than 1, it would be like line approaching the horizontal line. You can see here, yeah. I would like to see you on a pen. Yeah. When we got the m, yeah, uh, less than 1, yeah, m minus or plus. You can see that when it reach less than 1, yeah, it would like to be approaching the horizontal line. Okay, horizontal line. If m more than 1, it would approaching the vertical line. Yes, as you can see in this. Yeah. Both 1 minus or plus inside. Yeah, you can see if you're using the graphics. Yeah, this is plus side and this is minus side. Okay, if m of if gradients equals or exactly approach by 1, yeah, or minus 1, it was less by 45 degree. Okay, this is 45 degree. Now, this is the rules of the m. You can use this after you got the align algorithm or another algorithm, that you can use this as your alternative. So I will give you an example. If there are 2 points that will be connected, example the point A and the point B, the point A, as you can see on the bottom one, 2.2 and B 7.5. How can we draw this on the computer graphics or the pixel-based screen? Yeah, first you should uh, looking for the gradients by using the equations of the gradients that were equals by the difference y divided by difference x. Y2 minus y1, that will be 5 and 2. You can see this one. This is x1, y1, y1, x2, and y2. And we got the y2, so it will be 5. This one. This is the y side, and this is the x side. So it will be 5 minus 2 and 7 minus 2. So it will be 3 divided by 5. And after you got the gradients, it would be looking for the b or the intercept 1. The b you can use the equations before, yeah. As you can see here, the b intercept can be calculated by these equations, yeah, y1 minus m multiplied by x1. Yeah, y1 would be 2, yeah, on this one. Y1 is 2, and then m, as you can reach before, 3 divided by 5 and multiply by x1 or 2. So we got the 2 minus 3 divided by 5 multiplied by 2. It will be 4 divided by 5. So after this, we would like to use the straight line algorithm or straight line equations. As you can see before, it will be y, yeah, that equals by gradients multiplied by x plus b. Yeah, y, okay, and then you can use m or gradients multiplied by x plus b. This means also that we should looking for the y by using the x. Yeah, the x you can looking this by this one, this x-axis, that the x1 is 2 and the x2 is 7. So it would be through the rest of the number by x-axis. So it would be the 3, 4, 5, and 6. So we will looking this line, yeah, this line by using the x-axis, yeah. So we try to input the 3. Okay, I would like to use this y3, yeah, yeah, okay. Y3 is the m gradients, the 3 divide 5 as you can reach before, and multiple by x x3 and plus b. I forget, 4 divide 5. Okay, okay, okay. And then you can multiply it first, okay, by 9. 3 divide 5 multiple by 3, that will be 9 per, or 9 divide 5, and plus 4 multiplied by 5. It would be the 13. Okay, it would be 13 by 5. Or you can see if you divide into the floating, you can find it into the 2 multiplied by 3 divide 5. Yeah, you can see 5 multiplied by 2 and plus 3. Same with the 13 multiplied by 5. Yeah, you can try it also into the next point, yeah, by the axis x. Okay, it will be you can get the 2 multiplied by 3 divide 5, and 3 multiplied by 1 divide 5, 3 multiplied by 4 divide 5, and 4 multiplied by 2 divide 5. Okay, these solutions, as you can see, it would be have a floating point, a number of the decimals. So you can round it up, okay, round it up, yeah, by using the rules. Yeah, if you got the 0.5 more, yeah, if you got the number, the result, okay, multiply the more than 1 or 0.5, or 0 less than 0.5. If you got the result more than 0.5, you can round it up, and if you find less than 0.5, so you can round it down. Okay, more than n equals, more n equals. Okay, so you can get the 2 point or 15, yeah, 13 divided by 5, it would be like how much? 12, 13, okay, 13 divided by 5, it would be 2.6. Okay, okay, 2.6 mean 2 and 0 point 0.6. It would be more than 0.5. It would, so it will be rounded up. Okay, then 3 multiplied by 1 divide 5, it will be 0.2, so it will be round it down. And 3 multiplied by 4 divide 5, it will be 0.8, so we will round it up. And the last one is 2.2 divide 5. Okay, it will be 0.4, so we will round it down. So we got right now we got the x axis and also the y axis. The x axis 3 will got the y equals the 3, yeah. X4 will equals by y3, and y5 will be equals by y4, and also x6 will equals by y4. So here this one, yeah, you can see on the right screen how we got the next drawn pixel. So after this, you can make a straight line by using this. So as you can see, uh, there was a problem appear. The solution is very slowly. Because why? Because y it requires the operation by multiplying equal m or gradients by x. So we get the y by using or each x by multiplying m. And the second one will we will do the round up or round down the result of y. So we have one solutions that if we got before, yeah, we use the each x value for looking for the y. Now we swap, yeah, we swap into the x value of each y. So when we using the straight line equations, this one you can see, yeah, ymx and also plus b, you can swap it up, yeah, and down and move right and move left, and we can find that x will be y minus b divided by m, or the gradients. And the gradients is currently exists state right now that such as before previous equations, difference y and divide by difference x, and b intercepts equals y minus y1 minus m multiplied by x1. So the other solutions of the straight line is looking for the swap between x value and y value. So when we looking this, yeah, you can see that when we using the y value, it would be like two value only. But if you see on the x-axis, we need to use 5 value. So it would be more fasting. It would be more faster. Okay. As the previous, yeah, you can use the two x, yeah, by you looking this, yeah, y minus b divided by m. So the x, uh, so we are looking the x1, yeah, the x3, x for year 3, yeah, would be y, yeah, y means the 3 minus b for divide by 5 and divide by m, 3 divide by 5. Okay, now we can round or change it by divide by 5. So we've got the 15 divide by 5, and minus 4 will be 11 minus by 5, yeah, and 11 divided by 5, and 3 divided by 5. So as you can see, the multiple as in easy, yeah, the calculation, you can remove the 5 because it will be the same. 11 per 3 or equals by 3 multiplied by 2 divided by 3. We also using the round up, yeah. By rounding up, when you got the value, the last value with the more than zero, more than and equals by 0.5 or less than 0.5. So the 3 multiplied by 2.3, it would be like 0.6. So we will round it up and round it into the 4, and 5 multiplied by 1 divided 3, it will be 0.3. Okay, it also, yeah, the result may be still looking ugly, yeah, because it would be uh, not so uh, preciously, yeah, precise for making a straight line it with the what can I do by the pixel base, yeah. The other solutions, we have another algorithm that use the slope or the m, yeah, as you can see, yeah, on this slide, yeah. We already explained this page, yeah, for the slope when we the m minus or plus, yeah, is less than 1, it will be approaching horizontal line, and more than 1 will be approaching the vertical line, and if the m exactly 1, it will be slash 45 degree. And so the other solution, we will use the slope, yeah. If slope is on the line between -1 to 1, a solution that is to find the value y from each value of x, yeah. So it will make more solutions. If m is between -1 to 1, so we use y for each x, okay. And if a part of the slope value, so we would like to use x for each y. It depends on the value of uh, gradient or slope. So this is the DDA algorithm. DDA algorithm is a digital differentials analyzer. DDA use a line to conversion scan, yeah, line conversion scans algorithm by assembling the lines in the range of delta x or delta y, or difference x and difference y. It would be optimized to speed up line durations or drawing speed. Okay, DDA algorithms, yeah, consider the previous line drawing example. As you can see, as the previous drawing by the straight line, we can get the 2.23.2343 divide 5, and for uh, 0.3 multiplied by 1 divide 4, yeah, and soon, yeah. The coordinate x increase, you can see this one, the coordinate x increased by 1. But the coordinate y increased with the slope of the line. Yeah. The coordinate x, y increased with the slope of the line. When the slope is the range value between minus to the 1 and start on the starting point, it will be increasing the coordinate x by 1, then y can be calculated, yeah, yeah, if you -1 to 1, so the x can be calculated by 1. it can be plus by 1 directly, yeah, if you got the m between minus to 1. And y, you can calculate it by using yk, yeah, the previous y, using y, yeah, with the y2 plus m, 2 plus 4, 3 divide 5, yeah, and you can see you can get this point here, 2 and 3 divide 5. But when outside of the value of the minus 1 or apart the value, you can increase the coordinate or the swap, yeah, to y by 1 and calculate x by using the previous x and plus it by 1 minus m or m degree of minus 1. So the calculated value must be rounded to match the pixel value. As you can see before, it will be round up, yeah, the result of the calculations or the equations. So the conclusions, DDA is more faster. You can predict it by using the M slope. Because there's no multiplication operations, you can run it up, yeah, by x1 if you got the aim or the gradient between minus to 1, and you can round you can plus 1 the y if you get the outside of the range of the part of the slope range between minus 1 to 1, yeah, but there are a few problems. It would be accumulated rounding errors can keep pixels away from the line. Rounding and floating point operations are time consuming. Yeah, as you can see, the straight line is time consuming or the durations is too long. So the other solutions, we can use the line algorithm. Yeah, the next algorithm line is the Bresenham algorithm. It is an algorithm that is now used in modern computer graphics. It's better than DDA algorithms and the straight-line algorithm is also, because the incremental algorithm present value uses previous value and used for integer data only, yeah, avoid the floating point also. The present algorithm uses decision functions to determine the locations of the next coordinate. Okay, if I given you 2 points, x1 and y1, and also x2 uh, point y2, yeah, it would be looking for a connecting point between the 2 points. The assumption that the x2 is more bigger than x1 or x1 less than x2, and the aim is between 0 to 1. The first thing you should determine the starting point of the line x1 and y1, and also the end of the line x2 and y2, and initialize it by counting the difference in width and difference in height, yeah, and multiply the difference height with the 2 by 2, yeah, and the initial decision parameter you can set for the first time, yeah, it only used at the first time. Initial or the parameter for the first initial, it will be 2 multiplied by difference y or delta y minus delta x. And next, every x along the line starting at the k0, yeah, you can check the following points. The first one, you can see this: if the p, the parameter, the previous parameter is less, sorry, the current parameter is less than 0, so the next point you can draw it by plus x by 1 and y is currently exists, currently state. Then the p, the next parameter, you use this one. Yeah. If only the current p is less than 0. So the next p will be calculated by these equations. P plus 2 multiplied by delta y. Outside this, yeah, a part of this parameter, yeah, you can draw it, yeah, if more than 0 or equals than 0, you can run plus x by 1 and also plus 1 with the y. And the next p is using the current p plus by the 2 delta y multiplied by delta y and minus 2 multiplied by delta x. And you can remove and you can repeat the above step of delta x. And we are using the m parameters, m value. If m more than 1, so you can use these parameters only on the first parameter. Yeah, if every y, yeah, along the line starting at the k0, check the following conditions. As you can see this, if the current p or the current parameters is less than 0, you can run the y with the by 1 and x is stayed as the previous. And the next parameter will be equals by the current parameter plus 2 multiple delta x. Part of that, you can uh, plus 1 the x and plus 1 the y, and using the next parameter with the current parameter plus 2 delta x minus 2 delta y, and remove and repeat above step delta y. The example, if you given 2 points to be connected lines with the A20 point 10, yeah, 20 and 10, and B 30 and 18. So the first thing you should be calculated the m or the gradients. Delta y or difference in y uh, and difference in h, yeah, it will be 8 and 10, yeah, so you got the 0.8. As you can see the rules before, when you got the m more than 1, we should use these rules. If a part of this m more than 1, it would be using the x along the line. Okay, so we got the 0.8, so using the x, right, the x, the first x-axis. So we use these rules. We would like to check the current p. So the current p is using the 2, okay, sorry, it would be check the current p with this one, yeah, all the initial parameter. The parameter for the first time you should use this one, yeah, 2 2 delta y and minus by delta x. So we got the delta y with the 8 and the delta x with the 10. So 2 multiplied by 8 is 16 minus 10, which equals by 6. And then we got the 2 delta y is the 16, and 2 delta y minus 2 delta x will be 2 delta x will be 20, so it will be minus 4. So by using this rule, you can see, yeah, the current p is 6. Okay, the current p is 6. So yeah, it would be more than 0. So it will be used by this, and round dx, yeah, dx by 1 and y by 1. Okay, can see this? The first came 0, yeah, with the current p is 6, we can move, yeah, the x by 1 and the y with 1. Because the a is 20 and 10, we will move it to 21 by 20 plus 1 and 10 plus 1. Okay, okay. And then after this, okay, the we use this rule, so the next parameter we will use this current. The next parameter with the current parameter plus 2 delta y. The current parameter is 6 and plus by 2 delta y is 16. So, yeah, sorry, this one, sorry. The current P is the 6 and the plus 2 delta x minus 2 delta y is minus 4. So it will be 6 minus 4. It will be 2, okay? Yeah. The next game, yeah, is 2, and we check again, yeah, with this rule. The p is more than 0, so we still use these rules. We will round, we will plus the x by 1 and y with 1. Yeah, 21 to 22, 11 and 2, 12. And then the 2, yeah, the next we will use also this p, yeah, minus 2 plus minus p, yeah, okay, 2, the minus 2 to delta y minus delta x, yeah, delta y minus delta x. Now the delta y is yeah, with this one, yeah, x2 y2 and x1 y1 by this. So we got the new, yeah, the new result 2 delta y, yeah, delta y means 20 22, yeah, sorry, 30 minus the 22 is the 8, and 12 mm, 12 sorry, 13 30 minus 22 is 8, so this is will be 16, yeah, and then 30, okay, sorry, minus y will be 12 to 18 to 12, 6, so it will be 12, and the 2 with this difference x. Now the x will be 30 and the 20 with the egg, okay? Egg minus egg multiplied by 2 is 16. So we will also get minus 4. Minus 2 with the minus 4, okay? Oh, sorry. Uh, okay. The 2, yeah, the 2 and the minus 4, okay? We got the minus 2, yeah, okay. And see this one, yeah? This 2 minus by 4, we got the minus 2. So the rules now change to the upside. Yeah, that was current p now is the minus 2 or less than 0. So we will plus 1 only on the x-axis. So now the x on will be up will be plus by 1, and the y is state. And until the next, yeah, until the K9. So we have got the 30 to 18. Now, your task is please calculate it manually, yeah, by apply the algorithm of the present harm, yeah, using the rules before the previous rules, yeah, and make it manually by writing on your paper. So after that, you scan your task and collect it to the classroom. I think that's all from me. Thank you. If you have any questions, please ask on the classroom, yeah, or you can chat on the Google WhatsApp. Thank you. I close this by Alhamdulillah, Alhamdulillah, Rabbil Alamin. See you on the next meet. Thank you. Assalamualaikum. Assalamualaikum warahmatullahi wabarakatuh.